Gel Permeation Chromatography. These are the contents. Introduction. Gel Permeation Chromatography or Size Exclusion Chromatography, or also called as gel filtration, uses porous particles to separate molecules of different sizes. It is generally used to separate biological molecules and to determine molecular weights and molecular weight distributions of polymers. It is usually applied to large molecules or macromolecular complexes such as proteins and industrial polymers. When an aqueous solution is used to transport the sample through the column, the technique is known as gel filtration chromatography. When an organic solvent is used as a mobile phase, the technique is known as gel permeation chromatography. The separation of molecules is called fractionation. Size of pores in beads determines the exclusion limit, what goes through the beads and what goes around the beads. Now the principle. A mixture of molecules dissolved in liquid, that is the mobile phase, is applied to a chromatography column which contains a solid support in the form of microscopic spheres or beads, that is the stationary phase. The mass of beads within the column is often referred to as the column bed. The beads act as traps or sieves and function to filter small molecules which become temporarily trapped within the pores. Larger molecules pass around or are excluded from the beads. Large sample molecules cannot or can only partially penetrate the pores, whereas smaller molecules can access most or all pores. Thus, large molecules elute first, smaller molecules elute later, while molecules that can access all the pores elute last from the column. Particles of different sizes will elute or filter through a stationary phase at different rates. In this diagram, the porous polymer beads is the stationary phase, in which the protein mixture is added to column containing the cross-linked polymers. The protein molecules separate by size. Larger molecules pass more freely, appearing in the earlier fractions. In the another diagram, you can see very small molecules enter many pores in the gel, equilibrating between the gel and the moving buffer, and so travel slowly and are eluted later. The medium-sized molecules enter some pores in the gel, equilibrating between the gels and the moving buffer. Large molecules enter few pores in the gel and so travel rapidly and are eluted sooner. The total column volume Vt equal to Vg plus Vi plus V0, where Vg is the volume occupied by the packing, Vi is the volume of the solvent in the pores, and V0 is the free solvent volume, similar to injection volume. Now the components. The components are stationary phase, the mobile phase, the columns, the pump and the detectors. Stationary phase. Stationary phase semi-permeable porous beads with well-defined range of pore sizes. Beads are cross-linked polymers. Degree of cross-linking is controlled carefully to yield different pore sizes. Small pore sizes are used for rapid desalting of proteins or for protein purification. Intermediate pore sizes are used to separate relatively small proteins. Very large pore sizes are used for purification of biological complexes. Stationary phase used for gel exclusion chromatography include dextran, polyacrylamide and dextran polyacrylamide. Each is available with a variety of different ranges of pore size in the beads, permitting separation of macromolecules of different size. A good stationary phase should have the following properties. These are: it should be chemically inert, it should be inexpensive, it should not react with component to be separated, it should not react with the eluent, it should be colorless, uniform in size and shape, it should be mechanically stable. Soft gel, example, dextran. Polyacrylamide gels, separation of proteins. Semi-rigid gel, example, biobeads, separation of non-polar polymers in non-polar solvents. Highly rigid gels and glasses, separation of polar systems. In this diagram, you can see reservoir containing the eluent, that is the mobile phase. Below that is the sample. Then comes the column packed with stationary phase in contact with eluent throughout its length. Now the mobile phase, the liquid used to dissolve the biomolecules to make the mobile phase is usually called a buffer. The mixture of biomolecules dissolved in the buffer is called the sample. The choice of mobile phase to be used in any separation will depend on the type of separation to be achieved and component to be separated. The most common eluents in for polymers that dissolve at room temperatures are tetrahydrofuran, chloroform, dimethylformamide. The materials in the mobile phase, synthetic elastomers, that is polybutadiene or polyseroprene, solvent toluene. Materials like PS, PVC, styrene butadiene, epoxy resins and the solvent tetrahydrofuran. Materials like polyolefins and the solvent trichlorobenzene, polyurethane and the solvent dimethylformamide. The materials proteins and polysaccharides and the solvent water or buffer. Solvent selection. The solvents used for mobile phase of size exclusion chromatography are limited to those following criteria. The solvent must dissolve the sample completely. A solvent has different properties with solute in the eluent, typically with solvent refractive index, that is RI. Solvent must not degrade the sample during use, otherwise the viscosity of eluent will gradually increase over times. The solvent is not corrosive to any components of the equipment. Mobile phase preparation. High purity of solvent is recommended. Filter mobile phase solvents using 0.5 micron filter to remove any particular impurities such as dusts, insoluble salts. Antioxidant is added to trichlorobenzene to keep solvent stable in high temperature. Other additives eliminate adsorption or interaction of solutes with column packing materials, size exclusion chromatography. Sample preparation. The sample solution are supposed to be prepared in dilute concentration, that is less than 2 mg per milliliter. A good solvent can dissolve a sample in any proportion in a range of temperatures. Sample with broad molecular weight distribution may require higher concentrations. It is recommended to filter the sample solutions before injecting into columns in order to get rid of clogging and excessively high pressure problems. Generally, filtration is required to remove insoluble impurities. Do not agitate and filter samples that contain very high molecular weight. Now, the columns. Commercially available columns. Analytical column 7.5 to 8 mm diameter. Preparative columns 22 to 25 mm. Usual column lengths 25, 30, 50 and 60 cm. Recently, narrow bore columns 2 to 3 mm diameter have been introduced which save time. Selecting column. Shorter columns save time and solvent. Small particles, typically 5 mm, provide a better resolution. On the other hand, 5 mm or even 3 mm packings are more sensitive towards contamination by samples containing impurities. Particles as large as 20 mm have been recommended for very high molecular weight polymers. Small particle size packings can sometimes result in shear degradation of large polymer molecules because The space between particles is very narrow. Columns with different porosity or mixed bed columns provide a better separation. Handling columns. A column set should always be run in the same mobile phase, that is isocratic. Columns should never be operated in a backward direction. Care should also be taken in collecting columns or in sample injection. Replacing a clogged inlet frit is a dangerous operation which can reduce column performance. A damaged or dirty check valve of pump can also reduce column life. In this diagram, you can see the mobile phase, that is eluent, the injection valve, the column, loop, pump, detector, interface, and the data station. The pump. A highly constant flow rate has to be maintained during the entire chromatogram. This is very important in size exclusion chromatography. A change of the flow rate of only 0.1% can cause an error in molar mass of up to 10%. Most pumps can only reproduce the flow rate to 0.2 to 0.3%. Inline filters in the solvent reservoir may prevent particles from coming into the pump heads, which might damage the check valves or the pump seals. The types are syringe pumps, reciprocating pumps. Detector. Concentration sensitive detectors, bulk property detectors, refractive index detector, solute property detectors, ultraviolet absorption detector, evaporative detectors, evaporative light scattering detector ELSD, molar mass sensitive detectors, light scattering detectors, that are low angle light scattering LALS detectors, multi-angle light scattering MALS detectors, viscosity detectors, differential viscometers. Others are flame ionization detector, a mass spectrometer, or a Fourier transform infrared spectrometer. Now comes the advantages. Short analysis time, well-defined separation, narrow bands and good sensitivity. There is no sample loss. Small amount of mobile phase required. The flow rate can be set. Disadvantages: limited number of peaks that can be resolved within the short time scale of the gel permeation chromatography run. Filtrations must be performed before using the instrument to prevent dust and other particulates from ruining the columns and interfering with the detectors. The molecular masses of most of the chains will be too close for the GPC separation to show anything more than broad peaks. The application: protein fractionation, purification, molecular weight determination, separation of sugar, proteins, peptides, rubbers, and others on the basis of their size. This technique can be determined the quantitary structure of purified proteins. It is widely used technique for the purification and analysis of synthetic and biological polymers such as protein, polysaccharides, and nucleic acid. Various species of RNA and virus have been purified using agarose gels for desalting for copolymerization studies. Thank you.